So back on the bench today is my SD System Z80 starter kit. We've assembled this in a bunch of previous videos and played a bit with it. And today what I want to demo is a bunch of utilities that were written for it. I picked this up on eBay. The seller's name was Sad Engineer. I don't currently see this listed. There was a large download I got from him that had all kinds of stuff on single board computers and other stuff in it. And this was one of the ROM images that he had written for exercising the system here. And it can do base memory test, expansion memory test, a checksum reporter for various ROMs, a PIO test, key code counter interactive, real-time clock demonstration, countdown demonstration, those kinds of things. So I wanted to give this a play, see what all it can do. Right now, of course, I've got the ZBug monitor in, and I've got that ROM that I found someplace else that had the three little applications. It was like a memory test, a real-time clock. Anyhow, let's go ahead, power the system up. I've got 5 volts coming in over here. System did power up. I want to do an examine. If I can remember, memory examine. We can start looking at the ROM contents here. We can go to 0800. Oops, that's not what I wanted. Back to the monitor, 0800. Memory examine should be looking at this ROM here. I should be able to do 0800, execute. I haven't played with this for a while, and I don't remember where all the buttons are, and that's interesting that we ended up with that. Oh, actually 0800 was the memory test, I believe. So it's actually testing addresses of the memory here. So let's power this down and go ahead and remove this EPROM. If I can get it out of there. Hopefully my puller will get a good grip on it and do that. So these are burned into 2716s, the same as these are. My label printer is broken at the moment, so I couldn't label these as well. That's the National Semiconductor part. We're going to go ahead and throw it into the socket. Maybe it's got a pin issue. See if I can see what pin it didn't like. There it went down in. He talks about this in here, so let's just go ahead and switch 3 to PROM on reset on PROM 1. Apply power again and do a system reset, and it should be asking for what function do I want to run. So cool, that little ROM is working. So his code in this ROM uses the routines in the ZBug ROM to actually, I think, do things like drive the displays and that kind of stuff. So that's pretty cool. So let's go ahead and hit 0 and test base RAM, and it passed. Let's hit 1 and try to test expansion RAM, and immediately fails, and I would expect that because we have no RAM up here. So that's pretty cool. But it's testing, you know, it's the original RAM. It's testing. Let's get a checksum for the ZBug ROM. I have no idea what it should be, but I would expect that to be repeatable. Utility ROM, checksum, U33. So that would be, this one is the checksum of that ROM right there, the one we programmed to put in here. User PIO, C note below. Well, let's go back. There's a key code counter. Let's see. Let's look at. We'll start by displaying 0. Pressing any key will increment the counter in the address display. Displaying the hex code key in the. Okay, so if we go run function and we want to look at the key interactive, that's on A. So it's counting how many key presses there's been. let's go back. That key has a weight of 0. Weight of F makes sense. E, D, C, B, A. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numeric keys make sense. They are the actual hex values. We can look at what execute is. So execute's a 1, 0. Signal step's a 1, 1. Monitor's a 1, 2. Next is a 1, 3. 1, 4. 1, 5. 1, 6. 1, 7. 1, 9. 1A, 1B. And that's funny, I got those in sequence. I guessed at what the best order for them would have been, and I apparently got it right. So let's get back to the monitor. It's got a real-time clock demonstration. To start displaying, and allow you to key in the desired time. So let's put in 12:02:03. So 12:02 in 3 seconds. Pressing execute or mem will initiate. Okay. So that should be keeping time. Very cool, and it is. There's a countdown timer demonstration. So let's hit D here. And I'm assuming we do the same thing. We want to give it a countdown time. So let's give it 15 seconds. And see what happens when it counts down to 0. So this is testing things like the CTC. You know, various components of the system are being exercised as we do these things. Cool, down to end. So the CTC is what's generating the timings and the things here for the clock. So this is a good indication it's working. Key counter. Pretty cool. He's done a good job with this stuff. Let me dig out some 2102s. I happen to have, I did some digging in my vintage chips. I happen to have some 2102s that we can use to populate the second half of the board. So there's a whole mix of stuff on here. I think this is all probably static RAM 2114s, 2147s, 2101s, those are probably DRAMs, but it's just a mix. But over here, I've got my little collection of 2102s, you know, lots of 2114s, 31 TMM, 314 APL, the 2114s. But again, when you've been collecting for decades, this is kind of the stuff you end up with. So these are Intel parts. The date code, it's hard to say. It's hard to read. 7A495, I don't believe that's a date code. Let's populate out this second bank. Oh, 12th week of 77, the date code's on the bottom of the package. And let's see if we can get a second bank of memory that works. Why not, right? Looks like I've got 16 of the Intel parts here, I believe. Come on. Wow, it did not want to lift up out of there. Actually, we can power this up. Well, that wouldn't be much of a demonstration. I'd say leave one of the RAM chips out and see it fail. But we've already seen it fail with me trying to test the upper bank. Yeah, there was a lot of really interesting material and manuals and things for all kinds of single board computers. In that download, you know, he saw my videos on the system here, and he contacted me from my YouTube channel and said, you know, take a look at my eBay listing. I've got, you know, out for a download of software and manuals. And so I went ahead and took a look. It wasn't expensive at all. It was a digital download. Went ahead and ordered it. He sent me a link to download it. There's a lot of interesting stuff in it. I used to have a lot of single board computers. They have all been sold off over the years. This gets into the world of I just don't have infinite space to store stuff. There's really no one single board computer that I am, that's the machine I must have. That's interesting that there's apparently 14 of these and not 16. So the question is this bit 0 or is this bit 7? And we should be able to power up, run the memory test. It should fail immediately. And hopefully the displays will give me a hint which bit is bad. So let's bring the power on. Function extended memory was 1. So at address 2401 we got back an AB, and I suspect it wanted an AA. He's probably doing an AA55 pattern. That's a typical. So that would mean the least significant bit was probably a 1, which means that's probably the least significant bit right there. That's my guess, based on the behavior I just saw. One time I was a test engineer, worked on EPROMs and DRAMs, and so you kind of get used to thinking about things in those ways. Power supply back on, system reset to 85D7. Oh, 2, I'm hitting the wrong thing. I'm getting a checksum. We wanted 1 for expansion RAM. Hey, the expansion RAM now passes. That is pretty cool that I was able to add the expansion RAM in on this. This is really a neat little board. And I've said it in previous videos, this is something that I would have had just an incredible amount of fun with back in the day. If I could have afforded this back in the 70s, I would have quite potentially have bought it. I wire wrapped a couple single board systems back in the day with the Z80, but that's pretty cool. This stuff here works pretty well. Base RAM, pattern and mask test. So we can hit a key, we can run the base RAM, and it passes. We can run the upper block, and it passes. The expansion RAM, which is, like it says, U16 to U23. We can pull up a checksum of the Z-Bug. We can pull up a checksum of this ROM. It was 1997 before, so that matches. Spare ROM U34 is going to probably, well, it's going to be, let's see what it, yeah, F800. I'm sure this is being pulled up to all 1s. Well, it's reading FF off the bus for the 2K addresses in there and adding them together. So yeah, I think that makes sense. I don't remember. Can you actually run code out of this spot or just program in this spot? I honestly don't remember. Let's go ahead and get back to and do user PIO register test. So let's go ahead and run 8. We haven't run 8 before. Well, it passes. Let's go out and talking to the registers, and actually the registers in the PIO, not the CTC. That is the PIO there. So the parallel IO chip. And so this test 8. Ensure that no peripherals are connected to the PIO before running test. So yeah, so we actually probably see activity on the PIO as it was. I assume it's trying to test in and out both on the PIO. But you know, we've got a good PIO, it looks like. Key counter interactive test. We'll come back to it. Keys all work. They all are producing values that make sense. I mean, it works, so they should be. I really have to reset out of there. Real-time clock. It's option C. And I really don't know what time it is. I'm just going to call it 12 noon or 12 a.m. either way. And we'll let it run the clock here. And that is, of course, testing the CTC, the counter timer, clock chip. So pretty cool. Definitely pretty cool. Now I'm curious, since we're playing here, let me pull out a logic probe. Try not to drop stuff everywhere like I just did. Let me get on to a ground and a +5 connection. And that should have the logic probe powered up, and it does. Oh, did I crash it? I must have crashed it. Oh, those connections are really loose there. They're not great connections. So 8, I believe, was the PIO test. So let's look at the PIO outputs and see if they do anything. And you saw it when it tested. We actually saw it pulse. So it's actually driving PB7. I suspect PB6 will do the same thing. So as part of the testing, it's actually driving. It's setting the bits, these bits to output, and it's writing to them. Which is why his warning was don't have anything connected, because it might write to something you don't want it to and cause damage. There's the B strobe, A strobe. I think those are actually inputs. Yeah, we see the chip get busy there. It's been a while since I've dealt with the PIO. It's been a long time. But if we go to port A here, we should maybe see it act like port B or not. There it was. See, I would expect to see it try to write on port A. I actually need to do a project with this. I really do. And of course, I think these strobes are inputs, but A ready is an output saying, hey, the chip's busy. And of course, on the Z80 side, we will see activity. A15 is low, no surprise. We're running everything out of the lower 32K of the RAM address space. A14 is actually clocking, so we're someplace, we're using memory up through 32K. I don't know what's mapped where in here. But, we would expect to see these clocking. And of course, there's activity on the data bus. The refresh is running, even though those aren't DRAMs. It's just the design of the Z80. But that's pretty cool here. We can actually visually see the PIO test do something. Pretty cool. Get back. Real-time clock. I'll start again at either noon or midnight, whichever that would be. And I'll just let it sit here and run. Pretty cool. I'm not sure really what else at this point I can talk to here. In his downloadable package was the source code for the utilities, a Z80 assembler that looks like it'll run in a Windows 10 DOS window. At least it ran for me. Well written, easy to follow source code if you understand the Z80 and the basic hardware here. So, good job. Don't think there's a whole lot else left for me to demo here. We talked about the fact that I've got it set to PROM 1 on reset, which means it starts execution immediately out of this position. We are in read mode for this socket, not program mode, which actually, because we're in read mode, we could actually have a third ROM in there. That's very true. You could have 6K of ROM in here, 6K bytes. Wow. Impressive. I've got an 8K basic. Things I've thought about doing with this is adding a UART. So we've got RS-232. I've got an 8K basic that would run on here just fine. But but we need RAM. So I would need 8K in the bottom 8K of memory for the basic, and then everything above that would be RAM, which would mean, you know, I think there's enough room to add a 2764 over here for the 8K basic. Probably two 52, 256 kind of chips, or 32K by 8. I think they're 28 pin dips. There'd be plenty of room for that. UART's going to be 40 pin on the clock generator. There's enough room on here to actually turn this into a little machine that can run basic. And if we were smart about this, we could even use the C load, you know, the cassette functions here. I need to test those still. The C load and C save. Maybe that's what we do with this guy. And so we see if we can get basic running on him. That would be really pretty sweet. Don't know what else to say here. If you have ideas of what we could be doing on the board, let me know. I guess I'll wrap this one up, and we'll talk soon.